Hi guys, so today we'll be solving this problem called Unique Paths 2. Let's read it. A robot is located at the top left corner of a M cross N grid marked start in the diagram below. Robot can only move either down or right at any point in time. The robot is trying to reach the bottom right corner of the grid marked finish in the diagram. Now consider if some obstacle are added to the grids, how many unique paths would there be? An obstacle and space is marked as 1 and 0 respectively in the grid. So we've been given a matrix where a robot is starting at the 0th index and of the 0th row, and it needs to reach the end of the matrix, which is at the n minus 1 and m minus 1 index. Now, there is an obstacle in between. Maybe you suppose take it as a stone, and the robot needs to go to the end of the matrix, where is n minus 1, m minus 1 index. So, how many paths are possible to reach the end of the matrix? So, this is what we have to find here, and this is basically a simple you can solve it either by backtracking, or maybe you can solve it by dynamic programming. So in dynamic programming you find different ways to reach the end of the matrix. Uh, so I'll be solving it by memorization for you to understand it more in depth, how intuitively the problem is solved here. And it's a very easy to understand code, and I'll be explaining along when I code it. So let's start. So first we'll check if the matrix is empty or not. If it is empty, then we return 0. For that, obstacle grid dot size is equal to 0, or obstacle grid 0 dot size uh, is equal to 0, then we return 0. All right. So this is the base condition that we check. If the matrix is empty, then we return 0. There cannot be any unique path which can be found out. Now I'll be making a variable to store uh, the size of the row, and let me call it row, and size of the column 0 dot size. So I'll be storing this. Now we need an array, or maybe a dynamic array, for storing the number of possible ways when we will be finding different paths to reach the end of the matrix. So for that we will be making a vector 2D DP, because we have a 2D matrix, and we need to we need to store how many possible ways are uh, you know uh, are able at particular index in the matrix. So how many possible ways are to reach 1 comma 2, or 2 comma 1, or 2 comma 3. So that will be storing it in a 2D DP. So DP of size n, vector int m, and initializing it to 0. All right. Now let me create a variable answer, and let's call the recursion function called find path. So find path is a function where I'll be passing the start index of the robot and the ending index of the robot where it needs to reach, and I'll be passing as well as the grid which has been given to us, and the DP we created. And simply here I will be returning the answer, because I assume that this find path function, which is a magical function which returns the answer for the number of unique ways to reach the end of the matrix by the robot. So let's come to the find path function. What we will be doing here is let's just define the function. SR is the starting index of the robot, starting row, starting column, ending row, and ending column, and then we have vector or vector int obstacle grid, then also the DP that we will be storing the answer. So now we uh, first check if the obstacle grid of SR SC is equal to 1, then we return 0. So my basic, understanding of this function is that it finds us the unique path to put to each index in the matrix. Okay, so cumulating all of that, we'll reach the last index and we'll return the answer. So first we'll be writing the main part, which is to find the unique path. All right, so for that I'll be initializing a variable int count equal to 0, and I'll check if sr plus 1 is less than equal to ending row, then only I call the function find path, where I increase the row number, and everything is as it is. Then I also check if the column is increased, so it should be less than equal to the ending column, and find path, where I'll be increasing the column and EC, then obstacle grid and DP. Now in the last step we'll be just simply putting the answer into the DP of starting index and starting column, and that will be returning. Now let's write the base conditions that we need to find, we need to do to for us to store the answer in the DP. So for example, if the starting index, so the base condition would be the starting index, and the starting index in the starting column becomes equal to the ending index and ending column, ending row and ending column. So SR is equal to ER and SC is equal to EC. At that time, we return that, hey, we found the index at this place. And otherwise, we check uh, if DP of SR and SC, we already have the answer, then we simply return that. And I think, yeah, that would solve and get us the answer that we need in this problem. So let's run the code to see if everything is working fine. Hmm. All right. So it's clear also. Okay. Okay. Row. We've named it row, right? So column row -1 and column -1. Yeah, that works. Yeah, that is accepted. So let me just run through it again. First, we are checking if the matrix is empty. If it is empty, we return 0 because we can't find the unique path. Now we check the number of rows and number of columns. We store it in the variable row and column, and we make a matrix to store the answer, which is DP, and we'll be initializing it with the number of rows and with the number of columns that we have in the main matrix. Now we'll be calling this function called find path, which will be returning us the number of unique paths to reach the end of the matrix n-1 and m-1 index, and we'll be simply returning the answer from there. Now in the find path function, what we are doing is that we are checking first if the obstacle grid is having an obstacle, if the index which we are on is having obstacle which is equal to 1, then we return 0, because we know that we can't consider that path as a unique path. uh, and otherwise if we reach to the end of the first let me explain this part. So we have a variable called count. Count will be storing the number of unique paths that has on each row, each the piece of matrix that we are on. So it will be counting the number of unique paths till that piece, and it will be storing it in the DP. And then if we do, if SR plus 1 is less than equal to the ending row, then we know that we can call the another row which is there. And if SC plus 1 is less than equal to EC, which means that we are not at the ending column, we can call the next column. So this will return recursively the answer and store it in the count variable. And then if we reach the base condition at that SR is equal to ER and SC is equal to EC, that means we have reached the reached the final destination that the robot needs to be on, and we'll be returning the DP from there as one, that we have reached the last index. And then we'll be simply returning the DP, the last index answer, which is the count. So I hope you guys understood the problem. It is a very interesting problem. Do solve it. And I hope you guys understood it. Thank you.